Everybody, hope that you're doing okay and everybody is well. We're going to complete the second part of 9.2, which the section is entitled Composite Functions and Inverse Functions. We've already taken a look at composite functions, and now we're going to deal with what I believe to be the more important one, inverse functions. Now, here is what we mean by functions that happen to be inverse of one another. I'll kind of use this board up here as I bring forth this definition. The inverse function of function f is a function that undoes the operation that was done to function f. Let me kind of repeat that again. The inverse function of function f is the function that undoes the operation from function f. Undoes kind of means cancels out what was done in function f. Let's show you how this cancellation procedure, or how this undoing the operation of function f is illustrated. To verify, when we are looking at two functions, function f and function g, to illustrate that these two functions are inverse of one another, in other words, one undoes the other, or undoes the other, we have to show the composition of functions. So the first composite function that we're going to show is the f of g of x, which is the same thing here that we see f of g of x. And so because the function f appears first, we're going to begin with this function and kind of look at how it's going to be done, and you'll see the cancellation or the undoing of the operation of function f. We're going to take the output of function g, x plus 300, and we're going to substitute it, or it's going to become the domain of function f. So I wrote out the beginning. F of g of x means the same thing as f of g of x. And now in place of x, we're going to put the output of function g, x plus 300. So 300 has been added to the original amount. But then as we finish the writing out of function f, we're going to take 300 away. Let's do the mathematics. X plus 300 minus 300. And you see the undoing has taken place. What happened in function f, that operation that happened in f, was undone by the other function. And our answer is the original amount that we started off with. And I'm going to point to this little guy right here. This is always going to be the evaluation. This is always going to be the answer that you're going to get if we are looking at inverse functions. Because one will cancel the operation of the other, and when one cancels out that operation, you're left with the original amount. Now, just to be on the safe side, let's show the composition the other way. Let's do the g of f of x, which is g of f of x. And that means we're going to begin with function g, the x plus 300. And wherever we see x, we're going to allow the range or the output of function f it will become the domain of our new function over here. So in place of x, we'll put x minus 300, and then we'll add 300 at the end. And you can see once again, there is an undoing. There's a cancellation. The 300s cancel, and we're left with that value of x. When you are looking at two functions, they will be inverse functions if you form the composition of both functions, the composition of f with g, the composition with g of f. If, when you form that composition, if your final answer is the original amount x, that verifies that the two functions are inverse functions. So we want to come down to the notation that we use when we're talking about inverse functions. The inverse functions of f of x is equal to x minus 300, and g of x, which is equal to x plus 300, these inverse functions are usually named as follows. There's a little different notation that is used. F of x is equal to x minus 300. And instead of writing down the other named function, g of x, we ordinarily use a different type of notation that means the same thing as g of x, but it just doesn't use g of x. It's written in this way. F negative 1 of x, but actually what it translates to is this. F inverse, or the inverse of f, when the domain is x. The one thing that we want to make sure, while I'm pointing to this, that negative 1 that you see in that upper right-hand corner, that is not an exponent. That is not an exponent. It's the notation that's used to identify the inverse of function f. It's said again, f inverse of x, or the inverse of f, when the domain is x. This is ordinarily the way that we identify functions that are inverse of one another. Now, there is another key item that is important when we are talking about inverse functions. There is a relationship between the ordered pairs for function f and its inverse, function g. There is a relationship, and we're going to go to this little sheet of paper right here and try to promote it. This first table of values makes reference to function f. F of x equaling x minus 300. And the table on the right is actually function g, from what we most recently were talking about, but you can see on the sheet of paper I used the notation for the inverse of f. F inverse of x is equal to x plus 300. Now we've already shown that these two functions are inverse of one another, but I would like you to take a look at the two tables, the one on the left and the one on the right. The one on the left represents a table of values for function f, and the one on the right represents a table of values for the inverse of function f. We'll call it function g. I identified three random amounts. I just picked three random amounts to represent the original amount, or if you want to call it an original price. This is the domain, this is X, and this is the Y column. X is the member of the domain, and f of x equaling x minus 300 is the range or the y. What are we doing here? We're taking the original prices, the three different original prices, and we are showing a $300 deduction off of those original prices. So 1200 minus 300, 900, 1500 minus 300, 1200, 1800 minus 300, 1500. That's the first operation that was done in F, so to speak. Now let's kind of show the undoing a bit. Let's come over to the inverse of F, and we're going to begin with an X column for that function and its inverse function, F inverse of X is equal to X plus 300. We begin where we had left off here. The amount of X is 900 in this operation, and now the undoing is going to kind of take place because we're going to take that 900 and we're going to add 300 to it, and notice what we're back to. We're back to the original amount that we started off with. We started off with him, we ended with him. We started off over there in that proof with X. What did we end up with when we did the composite function? We ended up with X. We began with 1200, we ended with 1200, and so on. In the second one, we took this reduction price of 1200. It became then the domain of the inverse of F, and we added 300 to him, and we're at 1500, and back to him as well, and back to him again on the last one. Folks, while Kristen is holding that camera right up there, would you look at the ordered pairs for both of those tables? The ordered pairs for function F are xy, x, y, xy, xy. Look at the ordered pairs for the inverse of F. The values have been reversed. And you see reversing and inversing have a connection. The values for the inverse of F have been reversed from function F. You want to make sure that you know this rule about inverse functions. The ordered pair solutions for inverse functions will always be interchanged. They will always be reversed. If the ordered pairs for function F are xy, the ordered pairs for its inverse will be yx. Always. That is a truth. Always for inverse functions. Now, we started off by looking at an example where we showed how we can verify that two functions are inverse of one another. And we're going to take a look at another example. We're just going to go through the composite concept and show you why these are going to be inverse. So let's say that we have f of x is equal to x to the third plus 1, and g of x is equal to the cubed root of x minus 1. Now, part of your assignment in 9.2 is you're going to be given a couple of functions, and you are going to be asked to determine if these two functions are inverse functions of one another. So to determine if they're inverse, we need to find the composition of f with g, and then g with f. And if in both cases, when we form their compositions, if the end result for both of them is x, like we shared with the first one up there when we started off this video, if it ends up being x, then they are in fact inverse of one another. So we're going to start with this one first. And I'm just going to note it like this. I'm not going to show the FOG. We're going to find the composition of f with g of x. So that means we're going to begin with function f. And wherever we see the domain value of x, we're going to substitute the output of function g. So here we go. In place of x, him. Put a tuck, put him in there. Cradle that little radical in there. Close it off. We've got to take it to the third. I just substituted in place of x, him. That range, right in there. The exponent of 3 there, and then plus 1. Let's come down. If we take the cubed root of this radicand x minus 1, and we cube it, you get the radicand. When you square a radical, you get the radicand. When you cube a cubed root radical, you get the radicand. So all of this right here becomes, bring down plus 1. The ones cancel. F of g of x is equal to x. That seems to be a signal that those are going to be inverse. Let's do the other. Let's do the g of f of x. So we're going to take the output of f, x cubed plus 1, and we're going to substitute it in place of x in that radical. Bring down that radical, get that index of 3, in place of x, x cubed plus 1. I didn't have to parenthesize it, but I did. Bring down negative 1. Now let's simplify this. Index is 3. X cubed plus 1 minus 1. The 1's cancel out. We're left with the cubed root of x cubed. The cubed root of x cubed, x. So in both of these cases, we verified that these two functions are inverse. And the final statement that we would like you to write down would be this. The functions are f of x is equal to x cubed plus 1, and as soon as you then write and f inverse of x is equal to the cubed root of x minus 1. This puts kind of a final touch on the fact that they are inverse. because we've shown the notation. Now that's one of the skills that you're going to want to make sure that you are aware of in terms of dealing with inverse functions. Now there's one final piece to this that we want to look at. You're going to be given, in this next little section, you're going to be given a function. And we're going to find the inverse of each of these functions. And we're going to start off with this one right here. F of x is equal to 2x plus 7. Now, the procedure that we're going to use to find the inverse of these functions, it is a procedure that's called the switch and solve strategy. We're going to switch some things, and then we're going to solve the brand new equation. Where does the word switch come from? I'm going to come right back over to this chart again. When we were talking about the inverse functions here, we mentioned that the ordered pairs of inverse functions are always interchanged, or they're reversed. When you are given an equation, a function written as an equation, and we want to find its inverse, we're going to do a strategy that's called the switch and solve strategy. And step number 1 of that strategy is this. Replace the f of x with y. Replace f of x with y. So we have y is equal to 2x plus 7. Now you see, this is the equation for function f. We want to come up with the inverse equation, or the inverse function for f. And because the ordered pairs of inverse functions are interchanged, here's where the word switch comes in. We switch the y and the x. Where we see y, we put x. And where we see x, we put y. So let me back up to the steps. Here's the function that's been given to us. The direction, we want to find the inverse function to him. Step 1, replace the f of x with y, because f of x is y. Y is equal to 2x plus 7. Now the switch. In place of y, put x. And in place of x, put y. And the final thing that we do is take this new equation and solve it for y. Now I'm going to put the 2y plus 7 on the right, on the left. I wouldn't need to, but I'm going to. Now we solve this equation for y. -7, -7, and we'll have 2y is equal to x minus 7. Divide both sides by 2. And this new equation that we have, y is equal to x minus 7 over 2, if this equation represents a function, and there's no doubt about it, it represents a function, this equation will be the inverse of the given one. The final thing that we do is this. If it is a rightful function, we use the correct notation. In place of y, we put f inverse of x, is equal to x minus 7 over 2, and there's the inverse function. Now, folks, for a lack of time, I don't have the time, but I'm here to tell you this. If you wrote down f of x is equal to 2x plus 7 here, and over on that side you wrote the inverse of f of x is equal to x minus 7 over 2, and you formed the composition of both of them, you're going to get x. You'll get x, and undoing will take place. Now that's number one. We're going to do a total of 3 of them. Not going to take long. We're going to do a total of 3. What is this concept called? Finding the inverse of a given function. Number 2. F of x is equal to 4x cubed minus 1. Step 1. Replace f of x with y. Step 2. Switch. In place of y, x. In place of x, y. Now I'm going to move the binomial over to the left. I wouldn't have to, but it's just more conventional if we do. Now we're going to solve for y. Move the 1 over. Divide both sides by 4. And we'll get it down to y cubed is equal to x plus 1 over 4. And now to find the value of y, you could take it to a given power, or you could find its correct root. To find the correct root of y cubed, we would have to take the cubed root of y cubed. And I think I'll show that. If we take the cubed root of y cubed on the left, we're going to take the cubed root of the expression on the right. And we'll end up getting on the left, y is equal to the cubed root of x plus 1 over 4. And I'm telling you right now, I'm not going to show it, but if you were to form the composition of this new function with that original one up there, that would give you x. The final statement that we'll write down will be f inverse of x is equal to the cubed root of x plus 1 divided by 4. This puppy and this one are inverse of one another. One will undo the operation of the other. Now there's one more that we want to look at. It's a bit more of a challenge, but since I believe that you'll see it on the assignment, make sure that there's not a doubt about what has to be done. A little bit different, a little bit more work, a little bit more thought. F of x is equal to 2x minus 3 over x plus 1. Function. We want its inverse. Replace. We've got to show that y. Now switch. Where y is, now he's x. Where x is, he becomes y. Our goal: solve the equation for y. two terms that contain a y. But let's not get ahead of ourselves. We're going to have to get rid of the fraction. So we're going to have to multiply both sides by that y plus 1. So I'm going to kind of show it in this way right here on a brand new step. Multiplying the left-hand side by the y plus 1, the right-hand side by the y plus 1. Left-hand side, I believe it's going to be necessary that we distribute. I'm not going to be able to leave it in this form, because in that form we're not going to be able to get y isolated. So we're going to have to distribute on the left. And on the right, the y plus 1's go. We're going to be left with 2y minus 3. Okay. Now, in order to solve for y, we're going to have to get the two monomial terms that contain the y on the same side. Can't solve it for y leaving them on opposite. So I'm going to move this xy over to the right. I'm going to move that negative 3 over to the left. And we'll kind of have then something like this. 3 plus 1 is equal to 2y minus xy. On the left, we'll have a 4. And on the right, the only way that we're going to be able to get that solve for y is to somehow get that y isolated alone. And so we're going to have to factor. I think a lot of people that I'm talking to right now, as soon as you get it down to this binomial, you'd realize that we'd have to take a y out because it's a common factor. So we'll remove a y. And we'll be left with a 2 minus x. Now we're able to find the value of y. Divide the right-hand side by 2 minus x, and divide the left-hand side by 2 minus x, and we'll end up then getting this. Y is equal to 4 over 2 minus x. Folks, I just want to take a look at this from the beginning just to make sure that everything is okay. I want to make sure, number one, that I copied it down right, which I believe I did. Replaced him with y. He's the same. Switched. X is equal to 2y minus 3 over y plus 1. Multiplied both sides by y plus 1. Oh, that's where I lost it. Let's back it up. Instead of having xy plus 1, I kind of felt something was wrong. Glad I saw it. Xy plus x is equal to 2y minus 3. Sorry, but I'm human. Move that xy over to the right. We'll move the 3 over to the left. And we'll have an x plus 3 is equal to 2y minus xy. Bring down that x plus 3 on the left, and on the right, pull out a y. And that'll leave us with a 2 minus x. Divide the right by 2 minus x, and divide the left by 2 minus x. Looks better. We're going to get y is equal to x plus 3 over 2 minus x. We'll write it in its final statement in a moment, but what I'm saying to you is, when we get this written as f inverse of x is equal to x plus 3 over 2 minus x, if you were forming the composition of this function with this one, there would be undoing, there would be cancellation, and we would be left with x. This is the inverse function. So that's going to put a close on 9.2. And we'll move just a little bit further along as we move on here. So you take care of yourself and be good. Keep a smile on that face. Bye-bye.